hope that I am live now. Just give me a moment to let me check. Okay, that would be in here. Let's see, guys, if I am live. I cannot see myself live yet. I need to check it again. Give me some time. Yeah, maybe. Yeah, definitely. I am live, guys. I am live now. That's great. So, hi guys. So now you can ace your exams with Unacademy. So this is our very, you can say, new category that we have launched, especially for ICSE and ISC learners. Yeah, for ISC and ICSE board learners. And I am Kirti Sharma, as you can see here, right. As you can see here, I am your chemistry educator and my name is Kirti Sharma. Okay, so I guess we have missed that slide. Okay, so let me tell you, no issues. I'll tell you, I am Kirti Sharma. Chali, let's write. It will become more interesting. Okay, so yeah. Mhm. Um, I have lost. Just give me a moment, guys. Let me check. Yeah. So I am Kirti Sharma, your chemistry educator. And I have more than 5 years of teaching experience. And in this particular session, we will be discussing redox reaction. What we will be discussing, what we are going to learn today, it is redox reactions. All right. If you have attended lecture number 1, which was yesterday, so in that particular session you can say it was just a basic introduction about like what is oxidation, what is reduction, and what is a redox reaction and what does it mean. So everything we discussed. Okay, we are starting everything from the very basic, right? From the very basics. So it's gonna help you a lot, I believe. And let's get started with our lecture number 2. This is our lecture 2. Let me, yeah, this is our lecture 2. I hope, okay, you cannot see that it's written redox reaction here. Okay, so this is our redox reactions. Okay, I guess now you can see it, correct? Yeah, now you can see it. So it's redox reaction and today is lecture number 2. Let me change the color. And this is our lecture number 2. If you guys have not watched lecture number 1, then go and watch it. You'll find it like within a playlist or like within the channel, this ISC and ICSE boards, and propagate it, share it as much as you can. All right, that would be amazing. So let's get started with our lecture number 2. Before that, I would like to give you a brief introduction about what we have studied so far in the lecture number 1. So the very first thing, it is the applications of redox reactions. So we saw that it is used in various processes, various reactions, whether it's combustion or metallurgy or your normal displacement reactions. So your like redox reaction is present everywhere. All right, as you can see, your electrochemical cells and batteries and photosynthesis, and you can say the process of aging, right? Even the process of aging, which is happening inside our body, it is also a kind of redox reaction that you can say. All right, just let me share this session to the Telegram group so that the students will be here, right? Let me quickly yeah, I have shared it. And the Telegram link is given in the description of this video as well. So you can just simply connect with us on Telegram for like all the updates if you want to know when are the next classes. So you can so that you will be knowing it. Next, then we did oxidation and reduction reaction. So, a reaction in which oxidation and reduction occurs simultaneously, it is called a redox reaction. Redox में RED stands for reduction and OX stands for oxidation. So redox reaction is in which oxidation and reduction occurs simultaneously. Okay. Oxidation, we discussed that there are three ways by which we can define oxidation. So the very first one is simply oxidation means addition of oxygen आप कह सकते हो. Addition of oxygen or any other electronegative element other than the oxygen. We saw the examples as well when we added chlorine, fluorine, bromine, and the like sodium, I believe. That's the example which we did in the previous class. Or oxidation can also be defined as removal of hydrogen or removal of any other electropositive element आप कह सकते हो. And the most modern definition which we believe in now is the loss of electrons. So whenever there is a loss of electron, then it is called as oxidation. So there will be a species which will lose the electron. The other species will, you can say, accept the same electrons such that the whole reaction will take place. Okay. Let's move ahead. Now it's reduction. So as we discussed, reduction is simply opposite of oxidation. In oxidation, we discussed that it was addition of oxygen. So what would be reduction? Reduction will become the removal of oxygen or removal of any other, you can say electronegative substance or electronegative element. Okay. And in case of oxidation, we saw it was removal of hydrogen. So उसका reverse हो जाएगा reduction में. So it will become what? So it will become what? It will be addition of hydrogen or electropositive element. And similarly, oxidation was loss of electrons and reduction will become gain of electrons. So please remember these basic, you can say, terminologies, basic definitions, so that you will like, there should be not any kind of issue in your basics, right? अगर आपके basics में झोल है तो बहुत problem हो जाएगी आगे. So it's better let's deal with the basics first. We will start with the basics and we'll end at the brilliant level. Okay, so let's get started. We did reduction, then we did the development of oxidation reduction concept on the basis of addition or removal of oxygen. So we saw that whenever we add oxygen, we say that here magnesium is getting oxidized, carbon is getting oxidized, sulfur is getting oxidized in this manner. Okay, see, I told you na when we added fluorine, chlorine, and sulfur to magnesium, even this is called as oxidation because you are adding an electronegative element to magnesium. So, for oxidation to occur, it is not necessary that oxygen should be present. Okay, it might seem a bit अरे क्या हो गया है ना, but it happens this way. Okay, that's how we say. Let me check. Yeah, yeah, Okay. Reduction हमने देखा, it is simply the losing of oxygen. So as you can see here, copper oxide is getting reduced into copper. Okay. Then redox reaction based on losing and gaining of hydrogen. So whenever you convert like alkene to alkane, yani ke what you did, double bond to single bond. So you do reduction, you add hydrogen simply, okay? Or when you come from triple bond to double bond, means you converted alkyne to alkene. That is also reduction process because you add hydrogen in such cases. Okay, similarly, more examples are here. If like this is just a quick recap, okay, within 5 or 10 minutes, so that if anyone like watches with this particular lecture, he or she won't feel like left out. Okay, now let's move ahead. This was a very good example. As you can see clearly that here we are adding hydrogen, but this here sodium is not getting reduced, sodium is getting oxidized. Why? Because you added like a more electropositive element. ठीक है, electronegative element, my bad, electronegative element to this Na, sodium. All right, let's move ahead. So redox reaction based on losing and gaining of electrons, then we did. We saw the oxidation half reaction and then the reduction half reaction, such that when you add both the reactions, you get the whole reaction. Okay? Yeah, right. So that's what we did in the previous lecture. That's what we did in the previous lecture. Now we are getting started with our lecture number 2. Okay, so let's get started. And as I told you that my name is Kirti Sharma, and today we're gonna do redox reaction. Join the Telegram group for any other information and for all the notifications. Okay, and if you get plus subscription, if you get if you're planning to get plus subscription, I should say, you can use my code. This is my code, Kirti S Live. This is my code, Kirti S Live. Okay, and you will get additional 10% discount if you use this code. And if you are like, if you have never downloaded the Unacademy app, then it is the right time. Do it right away. And you need to select the goal for ISC class 11 or class 12. And in that particular category, I am teaching, and you'll find me, that's Kirti. And you can also search me on Unacademy app by my username. My username is Kirti underscore Sharma 1223. This is my username on Unacademy platform. So if you can unlock the free live class with this code, you can also unlock the free live class. These are the benefits. Unlocking the free live class, I'm telling you again that it's free for everybody. Unlock the free live class. This is what you can do. And number 2 is that you can get additional 10% off on plus subscriptions. All right. So this was the whole information about me and our amazing platform. Let's go ahead with our redox reaction, and today is lecture number 2. Today is lecture 2. Okay, so let's begin. Now we're gonna see what are oxidizing agent and what are reducing agents. Okay, so see, Oxidizing agent. If we talk about oxidizing agent, let's see. If we talk about oxidizing agent. So an oxidizing agent is the one who oxidizes others. It oxidizes others. दूसरों को oxidize करता है. Oxidizes others. If it is getting if it oxidizes others, it means it is you can say forcing another element to reduce its electrons, because oxidation is loss of electrons, right? It is forcing the other element to reduce electrons. So if it is forcing the other element to reduce the electrons, then the oxidizing agent itself will accept those electrons, right? So it oxidizes others, and if it is accepting the electrons, so what is it doing? The oxidizing agent is getting reduced itself, reduces itself. Okay, please remember this, like whichever the agent is, उसके साथ उसका opposite होता है, reduces itself. So an oxidizing agent oxidizes others and reduces itself. So please remember this. This is a very important information. All right. Now, if we talk about reducing agents, if we talk about reducing agents, so take a moment and think, what would reducing agent do? A reducing agent will reduce others. जो दूसरों को reduce करता है, it reduces others. Reduces others, and if it is forcing another element to reduce itself, means to gain electrons, right? So it reduces others and gets oxidized itself. Oxidizes itself. So this is about reducing agent and oxidizing agent. This was about oxidizing agent and reducing agent. So if the oxidizing agent, see, now if the oxidizing agent is oxidizing others, so what would the oxidizing agent do? It would easily, you can say, gain electrons, right? Oxidizing agent will easily gain electrons. And in case of reducing agent, what would the reducing agent do? It would easily loses electrons. Easily loses electrons. Okay, because it is getting oxidized itself. That's why. So I hope that the concept of this, oops, I have, let me, where were we? Where is the link of the class so that I can see your comments, your live chat, if you guys are there. All right, cool. So a reducing agent easily loses electrons. All right, cool. Now if we look at the reaction, now look at a reaction. If we say that 2Na plus half O2 is giving you Na2O. If 2Na plus half O2 is giving you Na2O. So here what is happening with sodium? Sodium is the reducing agent. Sodium यहाँ पे क्या है? Sodium is the reducing agent. Why? Because it is getting oxidized itself and it is reducing others. And oxygen is what? Oxygen is the oxidizing agent which oxidizes others. Here, and this is oxidizing agent. I believe that there is no doubt till now in oxidizing agent and in reducing agent. Okay. Now, one more thing which we need to remember is that जो जो भी metals होते हैं, the metals are good reducing agent. Why? Because metals want to lose electrons. Metals are good reducing agents. Metals क्या होते हैं? Metals are good reducing agents. Why? Because metals want to lose electrons. Metal क्या करना चाहते हैं? Metals electron को lose करना चाहते हैं. जैसे कि जो सोडियम है, these are alkali metals. कैसे metals है बच्चे? These are alkali metals. So what do they want? They want to lose electrons. And even the alkaline earth metals are good reducing agents. Okay. Now, if metals are, you can say good reducing agents, then who are the good, oxidizing agent? The oxidizing agent अच्छे कौन होंगे? Tell me. Who will be good oxidizing agent? Non-metals, you can say halogen family, oxygen family, correct? These will be the good oxidizing agents. So if you look through the periodic table, something like this, if you look through the periodic table, the one who are who are at the leftmost side, who are here at the left, ये कैसे होंगे? These are good reducing agents. These will be good reducing agents. What happened? Yeah, so this will be good reducing agents. And the one which are at the rightmost side, halogens, oxygen family, nitrogen family, these will be good oxidizing agents. Good oxidizing agents. Why? Because they want to gain electrons, right? Then what about these who are in between? So according to the situation which is given to them, they may behave as sometimes reducing agent and sometimes oxidizing agent, depending upon whether in order to complete their octet, they want to like receive an electron or they want to give away the electrons. Okay, so it may behave as both. May behave as both. ठीक है? So I hope कि इसमें at least कोई doubt नहीं होगा. There is no doubt in this. Okay? So let's see. Let's discuss further. So we discussed about oxidizing agents. Let's move further. Now you should like remember. Sorry. Now you should know about the important oxidizing agents. Let's write important oxidizing agents. So let's see के important oxidizing agents जो like which you need to remember. Okay, so that you just look at the reaction like, okay, this is the oxidizing agent, so that you can like uh, imagine the mechanism, like whatever is happening in the reaction. So good oxidizing agents are, you can say, number one, molecules made of electronegative elements. You can say molecules made of electronegative elements. Example: O2, oxygen gas; O3, ozone; X2 यानी कि halogens. So these are good oxidizing agents. See, that's what we have written here as well. Okay. Now, molecules made of electronegative elements. Let me check your comments. All right, then we can carry on, I believe. Yeah, we can move on. We can go ahead. Now comes number second. Yeah. So we can say compounds containing an element which is in the highest oxidation state. Right now, just remember it for a while. In the very, like after this topic, the topic which we need to cover is oxidation state itself. So you'll get it, but right now it will be in your notes. That's more important. Okay. Right now, just write it, and then like I'll remind you again. So let's write compounds compounds containing element compounds containing element in highest oxidation state. Example के तौर पे you can write KMNO4, we can write KMNO4, K2Cr2O7. I will like I'll tell you in which, like what is the oxidation state. Or all right, right now just note it down. It will be quite useful for us. Na2Cr2O7, Na2Cr2O7, CrO3, H2SO4. These are all good oxidizing agents. This is H2SO4. Right, this is H2SO4. So these are good oxidizing agents. All right. So let's discuss more. Is there any comment? इसके अलावा we can write HNO3 to be continued. We can say NaNO3. What else we can say? We can say, let's erase this. Yeah, we can write NaNO3. All right. We can say FeCl3. We can say HgCl2. These are all your good oxidizing agents. Apart from it, we can say oxides of some elements may also behave as oxidizing agent. Oxides of some elements. Oxides of some elements. For example, MgO, FeO, CrO3. These are some examples. CO2, you can say. CO2 may also behave as oxidizing agent. P4O10. This may also behave as oxidizing agent. और क्या लिख सकते हैं हम लोग? Any, you can say fluorine. Fluorine is the strongest reducing agent. Please note this. Fluorine. F. It is the strongest strongest oxidizing agent. Very electronegative. It is the strongest oxidizing agent. So we need to remember them so that we will just instantly get to know. All right, let's move ahead to important reducing agents. Now we'll do what? Important reducing agents. Important reducing agents. All right. So what are reducing agents? Those who reduces others and gets oxidized itself. तो जितने भी metals हैं सबसे पहले तो all the metals are reducing agents. All metals, right? All metals. So we can say that sodium, zinc, iron, aluminium, etc. All metals. Next, a few non-metals as well. Few non-metals also behave as reducing agent, जैसे कि कार्बन, जैसे कि हाइड्रोजन, जैसे कि sulfur. These may behave as reducing agents. Number 3, we can see some like hydroacids, जैसे कि HCr, HCl, HBr, HI. These may also behave as reducing agent. H2S. These also behave as reducing agents. Number 4, we can say that a few compounds containing elements in the lower oxidation state. For oxidizing agent was the one in which an element was in the highest possible oxidation state. यहाँ पे क्या है? Compound containing element, compound containing the element with lowest oxidation state. उसका opposite हो गया, just opposite of it. With lowest oxidation state. We'll discuss what oxidation state, oxidation numbers are. Don't worry about that, guys. It would be SnCl2, Hg2Cl2, Cu2O. These are the examples. Okay? So that's what we can say. And lithium and cesium are also reducing agents. Lithium is the, you can say, the strongest reducing agent. Who? Lithium. Lithium is the strongest reducing agent. Okay? And what else can you say? That cesium is strong reducing agent in the absence of water. Okay, cesium is reducing agent in absence of water. So these are the most important oxidizing agents and most important reducing agents. Okay? Now what are the tips if you want to get to know? Okay, usse pehle, what else can we do? I want to tell you some substances which may behave as oxidizing agent and reducing agents as well. Substances which can behave as both. Behave as both. Both what? You can say they can behave as oxidizing agent as well and reducing agent as well. दोनों की तरह वो बिहेव कर सकता है. एग्जाम्पल सबसे पहले is hydrogen peroxide. What is the example? Hydrogen peroxide, that is H2O2. Hydrogen peroxide. Very important example. Sulfur dioxide, SO2, H2SO3, HNO2, NaNO2, Na2SO3, या O3, ozone. It may behave as both. These are the compounds which may behave as oxidizing agent as well as reducing agent. Okay? Yeah. So I can see myself. Yeah. Cool. Yeah. So I guess that was it. Apart from it, if I give you some tips to remember, like if you see something, whether it's like an oxidizing agent or is it a reducing agent. So the best tip is, if a compound is in its highest possible oxidation state, which we will discuss right now, then it will be an oxidizing agent. If a compound contains an element which is in the lowest oxidation state, then it will be behaving as a reducing agent. If like a compound contains an element which is like an intermediate oxidation state, then it may behave as both oxidizing agent as well as reducing agent. Okay, so we are done with your oxidizing agent and reducing agent. Let me know if there is any doubt. Let me see your comments if there is any. Okay. So I guess you're just simply gonna watch the recorded session, I believe. Okay? Yeah. All right. Just quickly let me have some water. Okay. We can continue right now. We have some time. Hmm. Now look at oxidation state, or you can simply call it as oxidation number as well. You can call it as oxidation number as well. Okay, it can be termed as both. So for reactions that are not metal plus non-metal or do not involve oxygen gas, we need a method for determining how the electrons are transferred, right? Okay, so let me tell you what oxidation state or oxidation number refers to. See, oxidation numbers are a system that we can use to keep track of how many electrons are transferred. This is a very basic definition, that if you know the oxidation number, then you can tell how many electrons have been transferred. Okay, so oxidation numbers are a system that we can use to keep track of electron transfers. Oxidation, we know that it is loss of electrons, reduction is the gain of electrons, and the midpoint is oxidation and reduction go together. So whenever oxidation and reduction go together, what happens? It is called a redox reaction, right? It is called a redox reaction. So whenever a substance loses electrons and another substance gains electrons. That's what happened within a redox reaction. All right. So oxidation state up, you can also define it as Pavan. Hi Pavan. Hi bacha. Today we are discussing your chapter redox reaction, and today's lecture number 2. Since you are late, you can watch the session, you can watch the previous session as well, lecture 1, and the remaining of the lecture 2 as well. All right. And if you guys are from ISC and ICSE boards, then do circulate this video, this channel within your friends, within your family, within your cousins, so that we can all study together. We can all learn together. All right. So oxidation number is simply an imaginary charge. Okay, it is not an actual charge, it is just imaginary charge by which we get you can say convenience, we get to know how many electrons have been transferred. Okay, so basically oxidation number denotes the oxidation state of an element in a compound according to a set of rules. So there are some certain rules which we have set, okay, formulated on the basis that electron pair in a covalent bond belongs entirely to the more electrovalent bond. Okay, I guess it's quite clear now. And one more thing, don't get confused oxidation state with valency. Don't get confused between the two, oxidation state and your valency. Okay, valency is simply the combining capacity, right? So let's get started with some rules, you can say. So let's get started, it's gonna be fun, an easy topic. Where are these spammers coming from? I don't know. Okay. So here we have given some chemical species, and here we have given their oxidation state and some of the remarks, why is it happening. So any element which is in the form in which it exists naturally, in that case its oxidation state will be simply zero. Its oxidation state will be simply 0, like Fe, O2, S8. All right, yeah, Ag, Au, yani ki silver and gold, their oxidation state will be simply 0 whenever an element exists in the in its natural form. Okay, free form, so their oxidation state will be 0. These are some rules, these are some certain rules which have been given to us. Oxygen in any compound, so for oxygen it is -2 generally. Okay, see, as you can see here that it is -2, except इसके किसके अलावा, in peroxides. Peroxides is H2O2, Na2O2, right? Hydrogen peroxide this is. Then oxygen atom has oxidation state of -1. So generally in every case the oxidation state of oxygen is -2. It is -2. But in case of peroxides only, in case of peroxides only, the oxidation state is -1. The oxidation state is -1. Or in F2O, these are the things which we need to remember. Okay, in case of either peroxides or F2O, the oxidation state or oxidation number of oxygen will be -1. In F2O, then oxygen atom has oxidation state of +2. Okay. So this is something which we need to remember. Now about fluorine. Fluorine ka oxidation number is always -1. The oxidation number of fluorine is always -1. So it is sorted. Now comes hydrogen. Hydrogen is +1 except in metal hydrides, example NaH. Then hydrogen atom has oxidation state of -1 as metals have greater tendency to lose electrons. Alright. Now क्लोरीन ब्रोमीन आयोडीन यानी कि जो भी हमारे हेलोजेंस हैं, तो अगर if halogens are bonded to a less electronegative element, then their oxidation number will be -1. It will be positive oxidation state if bonded to a more electronegative element. जैसे कि अगर ClO negative है, then the oxidation state of chlorine will be +1. Okay, so if chlorine is bonded with a lesser electronegative element, in that case its oxidation number will be -1. But if chlorine is connected to a more electronegative element, then its oxidation number will become +1. Then it will become what? It will become simply +1. Let's move ahead. So again, we have something which says that oxidation number is a number that states electrical charge possessed by each one element atom in the molecule, compound or ion. So in the molecules of ionic compound, electric charge contained element atom can be raised by transferring the electrons. Okay, if this is somewhat confusing for you guys, let's move ahead for a while. You'll understand that. Okay, see, let's see the rules. Let's look at the rules first for writing the oxidation number. And in for tomorrow's session, we will do a lot of questions which are related to oxidation number in the next session. Okay. Yeah. All right. So in elements in the free or uncombined state, this we discussed that it will be 0. It will be simply 0. This we saw previously as well. For ions composed of only one atom, the oxidation number is equal to the charge on the ion. Suppose the ion is of simple atom like Na positive. So simply what would happen in that case? Its oxidation number will be +1. Its oxidation number will be +1. If it is Cl negative, the oxidation number will become -1. Okay? Okay, so you guys cannot see it. Say if it is Na positive, then the oxidation number will be simply +1. If it's Cl negative, then the oxidation number will be simply -1. ठीक है? If it is simply Cl negative, the oxidation number will be -1. Yeah. I don't know where are these spammers coming from. I'm just looking at the comment like in the live chat. So for oxygen, in the case of superoxides and peroxides, as we discussed, in the case of peroxides, the oxidation state will be -1. And in case of superoxides, as you can see, for oxygen, in the case of superoxides and peroxides, oxidation state is assigned to oxygen as -1 and or -1/2. It will be either -1 or it will be either -1/2. Okay, let's move ahead. So the second exception with oxygen is with fluorides and difluorides. Here the oxygen has an oxidation state of either +2 and +1. So this is something which you need to remember. This is something which you need to remember. Okay. The number assigned to oxygen will depend upon the bonding state of oxygen, but this will have a positive number. Let's look at the last rule, and that would be it for now. The oxidation state of hydrogen is +1 except when it is bonded with elements with binary compounds. See, you guys just need to remember these values, and in the next session, what we are going to do, we will be discussing, we'll be solving some problems so that it will be sorted with you guys. There will be like no issue. So that is it for the day, for today, and I'll see you guys in the next session. Tab tak ke liye, bye bye and all the best.